Today we're going to learn how to download and install MCU 8051 IDE, which is a software used to write, simulate, and debug programs for the 8051 microcontroller. We need MCU 8051 IDE because it simulates the microcontroller without needing real hardware. IT allows us to write programs in assembly language that IT can generate HEX files, which are used to run programs on real 8051 microcontrollers. IT shows register values, port outputs, and memory content, helping us understand the program flow. IT includes tools like calculator, find in files, and messages to help debug and learn. In short, it is a complete learning and development environment for 8051 programming. Open your browser and search for MCU 8051 IDE free download. Make sure to download from a trusted website. The downloaded file is usually an exe installer. Double-click the downloaded file. Click Next to continue through the installation wizard. Choose a destination folder. Default is usually fine. Click Install. After installation, click Finish. Now the MCU 8051 IDE is installed on your computer and ready to use. Find the MCU 8051 IDE icon on your desktop or in the Start menu. Click to open. You will see the main interface, which includes menus for File, Edit, Project, Simulator, and tools like Calculator, Find in Files, and Message windows. Create a new project. Click File, New Project. Choose a folder to save your project. Give it a name, for example, LED_blink. The IDE will create the project folder with initial files. Now we are ready to create our first program. The editor window opens. Copy or type your LED blinking code here. Save the file in your project folder. Click Project, Build Project, or press the Build button. The assembler will convert your ASM code into machine code. If there are errors, they appear in a message window. If there are no errors, the IDE will generate HEX, bin, LST, and ADF files. Click Simulator, start to run the program continuously, or click Step to run one instruction at a time. Observe port 1 pins, register values, and memory contents. If the program contains a loop, like blinking an LED, it will repeat until you click Stop. After writing the assembly program and clicking Build, the assembler converts a program into machine code. During this process, several files are generated. First is the ASM file. The .asm file is the assembly source file written by the programmer. It contains the instructions written in assembly language. This is the main file we create and edit. Next is the HEX file. The .hex file contains a machine code in hexadecimal format. This is the most important file because it is a file that is uploaded to the microcontroller or used in simulation software. Another file generated is the bin file. The .bin file contains a program in binary format. It is similar to the HEX file but stored as raw binary data. Then we have the LST file. The .lst file is called a listing file. It shows the assembly instructions, memory addresses, and machine code together. This file is mainly used for checking errors and debugging the program. Finally, there is the ADF file. The .adf file is used by the IDE for debugging and project settings. It helps the simulator manage the program during execution. So after building the project, the assembler generates several files such as ASM, HEX, bin, LST, and ADF. And among them, the HEX file is the most important because it is used to run the program on the microcontroller. If we remove the letter C from a call, the assembler cannot recognize the instruction. The LST file shows an error, and the HEX file cannot be generated. The solution is to write the instruction exactly as a call delay. In this video, we learn how to download and install MCU 8051 IDE, create a project, write an assembly program, build it, and run it in the simulator. We also learn how to fix LST file errors, like missing letters in a call. After building the program, the HEX file is generated. This HEX file is very important. It contains a machine code that can be uploaded directly to a real 8051 microcontroller. In our simulation, we also observe the LED on P1.0 blinking correctly, confirming the program works perfectly. Now it's your turn. Try writing your own programs. Experiment with ports, subroutines, and timers, and build them to generate HEX files for simulation or real hardware. If you found this video helpful, like, share, and subscribe for more microcontroller tutorials. Leave your questions in the comments. I'll be happy to help. That's all for today's lesson on MCU 8051. Thanks for watching, and see you in the next video.